Hello, thank you for tuning in to this fast chat on malware. My name is Daphne Krause, and today I'm speaking with Rampart AI's CEO, Krause. We are discussing malware that comes to life only after it is in a deployed environment and its impacts on businesses. So let's jump right in. Businesses and developers are now facing malware that waits to become active until an application is deployed. Where are we seeing this, and what are the impacts?
So, Daphne, I think the best place to start on this one is really looking at SolarWinds itself. SolarWinds is really the attack vector that brought this whole concept to life. The success of SolarWinds going undetected for 9+ months really created an exploit that people want to copy and take advantage of. And the real issue is that it can go through today's DevSevOps pipeline undetected, thereby bypassing all the security controls. This is extremely problematic. I think the shift left movement of catching everything in development, building better code, more secure code sounds great on paper, but it's really hard to implement since the security landscape is constantly changing. One underlying problem that exists is developers don't understand how the cyber game is played, and they need to ensure all the aspects of the system are operating correctly, and the bad actor only needs to find one. Developers assume the bad actor is outside the fence, when in reality, it could already be inside. This makes it very difficult to develop software not knowing what they're trying to protect. I think the layered approach is needed. The separation of responsibility and monitoring of your application at runtime really is where you're going to get your biggest bang for your buck. And I think that ultimately you want to detect abnormal behavior of the application during runtime. I think another thing that's really important to realize is SolarWinds came out with, this new sophisticated DevOps pipeline that they said would prevent a SolarWinds attack, and they're spending all this money trying to protect against yesterday's attack. And we always need to be looking forward at what the future attack is going to be, what the future attack vector is. And in order to do that, you really need to understand how your application is running at real time and is it behaving as expected. To be clear, I'm not saying forget about DevSevOps. I'm just saying it's unrealistic that DevSevOps is going to solve all the problems and that that's just one piece of the puzzle.
So let's talk a little bit more about SolarWinds for a second. It's obviously a very notorious malware attack. Can you explain what is now known about the attack vectors used during SolarWinds?
So SolarWinds is very well documented. So I'm going to focus on kind of the important aspects of it that people should realize. And they can go look historically what happened on the SolarWinds supply chain attack. The first aspect is it was supply chain related. And what really that means is that they were able to put code into the baseline and have it distributed as approved code, signed, sealed, and delivered by the SolarWinds application and spread throughout all of its user base. So really what's happening is someone now is going in and changing code behind your back. SolarWinds is not the first time something like this has happened. It's happened before. This is just the first time that it really got a huge bang for their buck from it. There's probably a lot of unknown exploits that are already sitting out there and people that push code into open source that haven't been taken advantage of yet. The second thing that's really important about SolarWinds is not only did they do that, but they also laid stealth for a while. And so during development testing and things of that nature, the exploit didn't come to life. It made sure that, Wireshark wasn't running. It made sure that it wasn't in a development environment. It waited a certain amount of time before it became active. And in addition to that, it kind of realized how SolarWinds in itself communicates and try to mirror the communication so it would be harder to pick up. And obviously, they were very successful. It took over 9 months to determine that it existed. And so I think the really big takeaway here is one, they changed trusted code into being untrusted. Two, they bypassed the DevSevOps pipeline by not coming to life until it was ultimately deployed. And three, they were, I guess, kind of sneaky about how they communicated outside to the outside world, mimicking how SolarWinds ultimately communicates to the outside world.
So you kind of talked about this before. how DevSecOps isn't the solution for application security. In your opinion, how are applications going to be secured in the future?
I think it's important. I think DevSecOps is an important part of application security. It's not the end all be all, and you can't solve the problem in application security purely in development because exploits continue to change. And so it's very difficult to keep your staff up to speed. It's very difficult to keep training everyone, and it's extremely expensive. So I think this is where we get DevSecOps to work for the first time, and then we forget about it, just like we develop software and we deploy it and we forget about it. It's very, very hard to maintain the life cycle and continue to maintain it. So that's really the problem that I see in the DevSecOps world. However, it's still important that we build better code. It's still important that we understand how our code operates. It's still important that we test our code properly. I'm not saying any of those things we shouldn't do. I'm saying be careful where you put all your money. Right, and I don't think all your money should go to DevSecOps. I think your money needs to go into testing of the app. I think your money needs to go into monitoring the app at runtime. I think your app needs to go into ensuring that you patch any known vulnerabilities. Those are the things, and realize what vulnerabilities are occurring at runtime are important aspects as well. That's really the point that I'm making. So I think the answer to your question, though, which is, in my opinion, how do we solve this problem? I think we solve this problem by ensuring we understand how our application is supposed to operate at runtime and ensuring that the application is operating as expected. And by doing that, we're able to detect changes and understand what's causing that change. We can potentially block bad behavior at that point. And in which case now, the most important thing about your application is how it operates at runtime during deployment, how it makes your money. Right. So those are the things that's most important. Development was just our starting point to developing software and ensuring it works as expected. But the end result is how it actually runs at deployment and ensuring it's running as expected. And I think that's the key, ensuring things run as expected at runtime.
So, in that regard, how are we protecting against this new attack vector that allows malware to stay dormant until it is in fact deployed?
So I think the real key there is that if you're able to build a behavior model, you understand how your application is supposed to work, then that's really what you tested and what you showed worked in development, right? When it goes to deployment now, you're using that behavior model to say, this is how our system's supposed to act. So if someone tries to deploy malware at deployment time, what's going to happen is it's going to be very quickly flagged as behavior that's not normal. And ultimately, at that point, it can be blocked or monitored, and you'll ultimately understand that something is not working the way it's expected.
Lee, thank you so much for your time. And to our listeners, thanks for sticking around. For more information about Rampart AI, head to rampart-ai.com. Until next time, stay secure.